we would think of this as 1 times t to the 0th power plus 0 times t to the 1st power minus 1 times t to the 2nd power. All right. When we say P2, we're talking about polynomial of order 2. So if it were P3, we'd go up to t to the 3rd power. Right? But basically what we're going to do is we're going to create basis vectors associated with the coefficients. All right? So my first one would be 1, 0, -1. The second one we would write as 0t to the 0th plus 1t to the 1st minus 1t to the 2nd. So 0, 1, -1. And then the last one, well, the coefficients are all there, so I don't think I need to rewrite it. 2, -1, 1. All right. So we want the ones that are relative to B. So in that universe. So I need x sub beta, knowing that x is 1, 3, -6. All right. So there's really nothing different because x equals beta times x sub beta. All right. And if you want to manipulate the general form, you could write it as, because we've been doing this every time, x sub beta is equal to the inverse of beta x. But regardless, I'm just changing my a and b in my calculator and just doing the same exact thing. And so we get this as my new vector. Aww. All right, now it follows the same format. Okay, power of 0, power of 1, power of 2. So this translates to 3 plus 2, we're using t, right? T minus t squared. Oh, thank you. Indeed it is. All right, so oh yeah, let me just say that thing. I'll talk more about that later because the calculus part of it kind of adds to it pretty nicely. And so now I think you're probably a little bit more ready for something like that. So put a star. I can still have that up there if you're still writing.